All right, here we go with another video. This is assignment 2B, not 2B. That's the question. So this assignment is dealing with what we call a frequency table. And this will round out, in essence, what you need to know for Chapter 2, a frequency table. So in a frequency table, we're going to be filling out this thing right here. And there's actually some mathematics that go into it. And I'll teach you everything that you need to know right now. Okay, so what we're going to do is we are given these numbers, and they just so happen to be in order. They go from 13 to 37 in order. And what we're going to do is we're going to take these numbers and we're going to, in essence, take a number line. Think of these as a number line. This number line starts at 13 and it goes to 37. And what we're going to do is we are going to take this and, in this situation, split it up into 5 equal-sized chunks. All right? So we're going to take 13 to 37 and we're going to break it up into 5 equal-sized chunks. And where I'm getting this 5 is just looking at the table, I see that I have to break it up into 5 different categories. Where if I look at the next one, next problem on the back side of this, you see that I'm going to be breaking it up into 4 equal-sized chunks. All right, so anyways, back to over here. We are breaking number 1 up into 5 equal-sized chunks because I'm getting that from my table itself. Now, what the big question is what are the numbers of those breaks? What are those numbers? Okay, and so here is where a lot of the math comes into play. Okay, so what I'm going to do is I'm going to, in essence, be creating this class boundaries, but I'm going to be making it over here, and this is what I call my rough draft. All right? Because I have to do something special to actually create the class boundary, but what I'm going to do is I'm going to make my rough draft, and this is what I use the most. To make this rough draft, what I'm going to first do is create what I call the magic number. The magic number. Magic number. All right. To find the magic number, what I do is I find the range that I have to cover. So again, what the word range means is how many numbers are from 13 to 37. And so what you do is you take the big number and you subtract the small number. Okay, and that gets you a range. All right, so in this particular case, that'd be 37 minus 13. And so I have a range of 24 numbers in between 13 and 37. So that's the amount of numbers that I have to split up. Okay, what do I do with that range? Well, I divide it by the number of categories that I need to fulfill. And what do you mean by categories? I mean how many how many rows do I need to satisfy? And so this is where I physically divide by the number 5. Okay, so on the other side, I'm going to be dividing by the number 4. Okay, so I'm taking 24 and I'm going to divide it up by 5. Okay, and this is going to get you some answer. Okay, this is going to get you some answer. You know, here it just so happens to be 4.8. Okay, you're going to get some answer here. And then what you do with this answer, and here's one thing that you kind of have to be tricky. Always go bigger. Make it bigger. Even if it's a perfect number, you always have to make it to the next number bigger than it. So here I have 4.8. Then I make it bigger, and I'm looking at the number 5. all right? Always make it bigger. Even if it were a perfect, you know, if the number were, so 4.8, that becomes the number 5. Even if it's a small number, like 4.2, that becomes the number 5. Even if it's a perfect 4, it becomes the number 5. Always, 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 always make it bigger. Okay, so I'll walk through this one and let's create the magic number to this problem. All right, so again, 37 is the biggest number. I subtract 13. Okay, this makes that range. So 37 minus 13, I have a range of 24. What do I do that? I divide by the number of categories that I need to have, and that happens to be the number 5. That gets me to a number of 4.8. And then what do I do with that number? I always make it bigger. So that becomes the number 5. So 5 is my magic number. 5 is my magic number. And now I need to do a lot with this number 5. Okay, so that is a big part where we have a lot of math involved, and now we get to use the math. What did that do for us? Okay, so as I said, what I'm trying to create is this rough draft. What are my boundaries in essence going to be? All right, so what I'm going to do is I'm going to start with the number 13, and as I said, I'm breaking this up into 5 equal-sized chunks. And I'm going to end up at least 37. Okay, at least 37. I can end up a little bit bigger than 37, but I can't end up smaller than 37. Okay, so what I'm going to do is I'm going to start with the number 13. And what the magic number does is it gives you the number of numbers that are in each boundary. So a lot of you knuckleheads will think, oh, well, that will go up to 18. If there's 5 numbers in that boundary, that will go up to the number 18. And there you would be wrong. What? There you would be wrong. Let's count it together. You start at 13, so there's 1 number there. 2, 3, 4, 5. What? 5. It's because 13 is kind of like technically 0. So this boundary only goes up to the number 17. There you will actually have 5 numbers in that boundary. You will have 5 numbers in that boundary. Okay, so what do I do to kind of fix this problem? So I know that I'm starting at 13. So what I do with that magic number of 5, is I don't add across. I don't add 5 going that way, but rather I add 5 going down. So the next category is going to start at 18. And then the next category below that is going to start at 23. The next category below that is going to start at 28. The one below that is going to be 33. And then I take 1 extra. I take 1 extra. So I add that magic number going down, not going across. All right, I go down. So the question still remains, where do these boundaries end? Well, we already kind of talked about how this boundary is going to end at 17. How can I tell that when I've created these numbers? Well, where these boundaries are going to end is 1 less of where the next one begins. Thus, the reason for that 1 extra. So this very first boundary, the one that starts with 13, will end at 17. The boundary that begins with 18 will end at 22. 27, 32, and 37. again, where those second numbers were obtained is where the next number begins. Excuse me, it's one less of where the next category begins. So for instance, in this very first, I see that this begins at 18, so one less would be 17. This one begins at 23. That means the previous one has to end at 22. That's where those numbers are obtained. Okay. So we have our rough draft of our class boundaries, and this is the hardest part to construct. Okay, so we made our magic number, and then we begin this with the smallest number that you have. Okay, and then you add the magic number going down, and then it's one less to find where those boundaries end. Okay, now what are the actual class boundaries? All right, so here again, we're going to kind of have to talk about a histogram here. Right, so think of a histogram. Okay, I know we didn't really get into histograms super, but hopefully you'll remember that histograms are bars that touch. But they come in chronological order. Okay, so they come in chronological order. So what does that mean? All right, so think of this bottom line as being a number line. And so I'll say, hey, this is the number 13. Then we have 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, et cetera, et cetera, et cetera. All right, so in our histogram, all right, notice that our very first boundary begins at 13 and ends at 17. So it would begin at 13 and end at 17. Okay, this would be our first boundary. Okay. Our next boundary begins at 18 and goes to 22. So it begins at 18 and goes to 22. Okay. And so there is that second boundary. Okay, how I began this is we are going to be asked to construct a histogram with this information. And the key number one most important thing about a histogram is the bars touch. The bars touch. Take a look at our picture here. Are those bars touching? No, they're obviously not touching. So how do I fix that problem? What do I do to fix my bars not touching? Okay, well, what I do to fix my bars not touching is I am just physically going to make these bars wider. So if this ends at 17 and this begins at 18, and I want to kind of like split the difference, where would those bars touch? Well, they would touch in between 17 and 18. What's right in between 17 and 18? 17.5, of course. So what I'm going to do is I'm going to make this blue bar a little bit bigger. And I'm going to make this red bar a little bit smaller. And so I'm making the high sides a little bit bigger and the low sides a little bit lower. Now, I just don't get to do it to just these specific sides. What you do is you do it to the entire bar. You do it to the entire bar itself. You make the bars wider. So what I'm saying is the low sides get lower, and the high sides get higher. And how much lower and higher do they get? Well, they get lower and higher by a half. So we're just taking these bars, just taking a bar, and we're just making them wider. That's all we're doing. And so that is what the boundaries are. So if this boundary was at 13 and ended at 17, okay, where it's actually going to start is going to be at 12.5, and it's going to end at 17.5. It gets a little bit lower and a little bit higher. So the lows get low and the highs get high. So back to our numbers. So again, as I said, this first boundary is 13 to 17. So the low, the 13, gets a little bit lower. So the actual boundary is going to be 12.5. And the highs get higher. The 17 gets a little bit bigger. The next category began at 18. So the lows get lower. A half lower than 18 is 17.5. And the highs get high, 22.5. Now notice how the boundary of that first boundary, 12 to 12.5 to 17.5, is now technically touching the second boundary that begins at 17.5. So these things are now touching right there. So we are now creating mathematically a histogram. So this would be 22.5 to 27.5. 27.5 to 32.5, 32.5 to 37.5. And there is your actual class boundaries. Okay, I'll do this again when I hit the other side of this assignment. So I'll talk through the magic number and everything. But just at a little bit quicker pace. But this is the hardest part of a frequency table. Okay, next is the midpoint. Hopefully you have gone over this in some of the math class. What the midpoint is the middle of any two numbers. Think of any two numbers in the universe, and I know how to find the middle of them. What you do is you take the two numbers and you add them up, and then you divide by 2. That is the midpoint. So what am I asked to find the midpoint in this problem? Well, it's of the 12.5 and the 17.5. Or 13 and 17. You'll get the same number. I can explain why you'll get the same number. But you're finding the middle of those numbers. So the very first category is 13 and 17. So I add them up and divide by 2. The midpoint will be 15. Okay, again, that will work with 12.5 and 17.5. So 12.5 and 17.5, the middle would be 15. It's again, like if this begins at 13 and 17, what's the middle of 13 and 17? 15. Well, what if I make it a half smaller and a half bigger? What's the middle of that? Well, the middle is still the middle. If you get more left and more right, the middle doesn't change, right? So that's the idea that why you can use 13 and 17, or you could use the 12.5 and 17.5. You're not changing the middle of the numbers. So for simplicity's sake, what I usually do is I use my rough draft. So 18 and 22, 23 and 27. 28 and 32. And notice how the midpoint is also going up by the magic number. Whoa. So notice how the midpoint is also going up by the magic number. Frequency, okay, frequency is, it's easy. It's the number of. It's the number of. It's like, so it's literally counting. So in category 1, we're talking about numbers 13 to 17. So what the frequency is literally how many numbers is that? And I'm not saying 13 to 17, that's 5 numbers. What I'm saying is of our list, okay, of this top number list, how many numbers are physically there that are 13 to 17. And so this is just counting. So 13 to 17 would be those two numbers right there. So the frequency would be 2. 18 to 22 would be those three numbers. 23 to 27. Or 10 numbers right there. Uh, 28 to 32. Did I miscount that? Let me go 28. Oh, shoot. Sorry. All right, 33 to 37. Okay, I'm going to skip over the relative frequency just for a second. I'll come back to it. And I'm going to jump to the cumulative frequency, What the cumulative frequency is, you may have heard of it, like when you're talking about a weather report, the accumulation, starting with the letter A, accumulation. The cumulative frequency is the frequencies added up to that point. All right, so what I'm talking about is this. To this very top bar, what are all of the frequencies added up from the top to that point? Well, it's just the number 2, so the cumulative frequency would be 2. Okay, in the second bar, what are all of the frequencies added up from the top to that point? Well, it would be the 2 and the 3. So that's 5. All right. What would it be to the third line? Well, it's all of the frequencies from the top added up. So that's 2 plus 3 plus 10. The frequencies of the first category, second category, and third category. The frequencies are 2, 3, and 10, so they add up to be 15. All right, to the next category. What are the frequencies added up to that point? That would be 2 plus 3 plus 10 plus 12. And so that would be 27. And last but not least is the number 4 joining the party, and that would be 31. A quick check to kind of make sure that you are on the right path and that you didn't miss a number or something weird or something like that is your total cumulative frequency, 31, should literally be the number of numbers that you have there. So I see that this is like a 4 by 1, 2, 3, 4, 5, 6, 7, 8. It's a 4 by 8, which is 4 by 8 is 32. But notice how you're missing one number. So that is 31. So 31 numbers, 31 numbers. Okay, so it's a quick check that you probably want to do as you go along, because if those numbers are different, then everything is going to be wrong. Okay, so you literally just add the frequencies up to that point. All right, so the number is 31. There's 31 total numbers in our list. And why is that important? Well, because now we're going to be talking about the relative frequency. The relative frequency, the relative, is like a percentage, but just as a decimal. And again, how do I create a percentage? Well, you take the number of somethings out of the total. Okay? It's the small divided by the big. All right? So it's a percentage. So relative, what am I making a percentage of? I'm making a percentage of the frequencies. So of that category, the very top category, category 1, what is its frequency? Oh, its frequency is 2. All right, so that is the top number. It's the number that belongs to it, divided by the total. What is the total frequency? And that would be that 31. There's 31 total numbers. So this very first category is 2 out of 31. And I want these answers as decimals. So this relative frequency is 0.0645. All right, this next one, what is the frequency of that category? 3. What is the total frequency? 31. So this is going to be 3 out of 31. Again, this is like a percentage. There's 9% of the numbers here. Okay, don't forget to round to that 4th decimal. 10 out of 31, 12 out of 31, and 4 out of 31. Oh, I messed up a little bit. 0.3226. 4 I got right. 1290. I messed up on the 12. There it is. 3871. Also, if you've done everything correctly, if you add up those relative frequencies, everything should add up to 100%. 100%. So 100% as a number should be the number 1. So if I add up all of these relative frequencies, it should be exactly or gosh darn close to the number 1 itself. Haha, what do you know? All right, so if I add up all of those relative frequencies, it should be 1 or very, very, very close to the number 1. All right, so that is your frequency table. Again, I'll do it quickly on the backside. Number 2 says roughly draw a relative frequency histogram from the information above. All right, so here we go. Histogram as bars touching. So this is going to be 12.5 in the first bar. It's going to go to 17.5. So that is kind of like the width that I'm dealing with. This goes to 22. Same width. 27. Same width. 32. Same width. And 37.5. Okay, so that's where the bars begin and end. And again, this is going to be of the relative frequency. So I'm making a histogram of the relative frequency. So I see that the biggest relative frequency is approximately 0.38. So just for simplicity's sake, I'm going to go a little bit bigger. Start at 0. So this would be 0.2, it would be 0.3, it would be 0.1. And then just kind of roughly make your bars to those approximate levels. So the very first one is at 0.6. Then we're at 0.9. Then we're at 3.2. Then we have 3.8. And then we have 0.12. There you go. All right, let's go ahead and hit the gas and do this a lot faster. Okay, so the first thing that I need to do is find the magic number. So I take the big minus the small. Divide that up into the correct number of categories. So I see that there's 1, 2, 3, 4 categories. Okay, regardless of what that number is, I'm always going to make that number to the next number bigger. So my magic number in this case is 47. So 47. So now I'm going to work on my rough draft. What I do is I begin with the smallest number, and I add the magic number going down. So 15 plus 47. So that means the next category is going to begin at 62. I take one extra because I need to know where these class boundaries end. And they will end at one less of where the next one begins. So if the first category begins at 15 and goes to question mark, what is that question mark? Well, it's one less of where the next one begins. So I see the next one, 62, begins at 62. So this first category would have to end at 61. The next one begins at 109, so this would be 108. 156, so that's 155. 203, so the last one ends at 202. The actual class boundary is the lows get lower and the highs get higher by a half. So if this is 15, it's actually 14 and a half. So the low got lower, now the high has to get higher. So 61 gets bigger by a half. And now these things are going to link together. So this is going to be 61 and a half, 108 and a half, 108 and a half, right, to 155 and a half, 155 and a half, to 202 and a half. Okay, that's the class boundary. The midpoint. Again, the midpoint is you add the two numbers and you divide by 2. So for instance, 15 and 61 is 38. You can absolutely have this number be a 0.5 number. Sometimes the middle is a 0.5, which is fine. It's fine. You're not doing anything wrong. All right, so 62 and 108. 109 and 155. 156 and 202. And again, these numbers should be the magic number itself. So for instance, 38 plus 47 plus 47 plus 47. You're getting the midpoints as you go along. If you can find the first one, you can use the magic number. Okay, frequency is the number of numbers in that category. So the first category goes from 15 to 61. So that'd be 1, 2, 3, 4, 5, 6, 7, 8, 8. The next one is 62 to 108. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Holy cow. 108 to 155. That's 1, 2, 3. 156 to 202. Red. 1. I'm going to jump to the cumulative frequency. So the frequency to the first point is 8 plus 20 plus 3 plus 1. Take a quick glance to see if that is the appropriate number. So I see that this is a 4 by 1, 2, 3, 4, 5, 6, 7, 8. It's a 4 by 8. 4 by 8 is 32. And so, yeah, I'm on the right track. The relative frequency is like a percentage. And so what that is the individual number divided by the total. So this very first category, the frequency is 8. So this would be 8 out of the total. This would be 20 out of the total. 3 out of the total. 1 out of the total. And again, I want these as 4-digit decimals. So 8 out of 32, 20 out of 32, 3 out of 32, and 1 out of 32. So this is going to be 0.25, 0.625, 0.0938, and 0.0313. Create a rough histogram. So I have, what, 4 categories here? 1, 2, 3, 4. I have 4 categories. And so this begins at 14.5, 61.5, 108.5, 155.5, and 202.5. Okay, this is of the relative frequency. So the largest relative frequency is 0.62. So I would probably take this up to a 0.7. So this would be 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. All right, the very first bar is 0.25. The next one is 0.625. 0.09, and then 0.03. Roughly, that's correct. It's a histogram, the bars touch, et cetera, et cetera. So that should be it.